Hello and welcome back to Pure Science Education. I thank all my subscribers to be loyal and been subscribed so far and watching the videos, and I hope you're enjoying all the new additions so far, and if you have any suggestions then please leave a comment. So we will be looking at another physics video for you, and today we are focusing on alternative currents. So what is the difference between an alternative and a direct current, and how does the United Kingdom have its current using the national grid supplied to your house? So if you're looking at DC, that means direct current, and an easy way for your exams to remember this is if you have any appliance that uses any form of battery, then it's a DC. And if you have any appliance that uses any form of electricity where you have to plug in your appliance into the mains, then it's AC. So the difference between the two, if it's a DC, it's got one direction that a charge travels in. And if it's an AC, the charge travels in the opposite direction as well as one direction. The voltage will change from positive to negative as it goes back and forth in an AC, but whereas in a DC, because it's going in one direction, you'll have a positive negative as you will see it on a battery. This diagram here shows you, if you look at the blue line, that's DC because there's a flat line going straight, and if you look at the lines going up and down, and that's an AC because it changes from positive to negative as the current flows through it. Now, the way the electricity flows in the United Kingdom, it is delivered to your house using the national grid. Now, the national grid distributes electricity from the power station to your house using different appliances in the middle. So our house outlet produces a voltage of 230 watts. For the best efficiency, the power generations of 25,000 watts. And then this gas carried through the wires. Now we use transformers to change the voltage because if you was to travel that amount directly into the house, that's quite a lot, and it's bound to get electrocution shocks and so on. So we have something called generators and step and step down. So this picture here shows you a diagram of something you have probably seen around in the streets when you are out and about, and they're normally heavily caged and it says to stay away. These are called transformers, and their job is to change the voltage from the power station to the voltage that can be then delivered to your house. So the way this works is, as you can see in the diagram, you have transformers that change the current voltage. You start with the power station, and if you increase the voltage, the current will decrease, and this is called a step-up transformer. And if you decrease the voltage, the current increases, and that's called a step-down transformer. High voltage and low current gives the best efficiency for the power transfer. And you will see that the power station produces a 12 kilowatts that goes into a step-up transformer, which increases the voltage but decreasing the current. It then goes through pylons, which you will also see when you go out and about, and they're all normally in open, distinct places. Then you have a transformer that steps down, and then you got the electricity going into your house just before by a step-down transformer. The national grid is made up of step-up transformer, power cables from the power station, step-down transformer, and power cables that go into your local area that then supplies you with electricity. The national grid doesn't include power station itself. So very quickly, just going through AC and DC again. So AC was alternative current, DC was direct current. And as I said, an easy way to remember this is if you're plugging something into your mains, then it's AC. And if you just physically put it in a battery, like an appliance in a toy car or your phone batteries and so on, they're all DC. We very quickly looked at how a power station can also be used as the national grid to supply electricity to a house using step-up and step-down transformers. You normally tend to get a GCSE question where you need to explain where these step-up and step-down take place when the electricity has been transferred from the power station to your house. So I hope this helps. Thanks for listening.